Yeah. Yeah. Good evening, everyone. So myself, I am Vijay. I hold 14 plus years of experience, which includes 7 plus years of experience in big data, Hadoop and Spark environment. So as part of today's session, right, just I am going to cover the following things. So before I start, can anyone please confirm whether my voice is clear, whether my screen is visible or not, right?
Yeah, your voice is clear.
Yeah, thank you. So what is big data? Why Hadoop? So already we have got many technologies available, right? And what are the main drawbacks we are going to see with the databases as compared with Hadoop? Drawbacks with databases. Hadoop advantages. Hadoop ecosystem components, right? And Hadoop and Spark job market. Hadoop and Spark job market. Okay. So both as part of the course, we are just going to discuss like Hadoop and Spark, right? So, big data, Hadoop and Spark. So the demo, just I'll be discussing these concepts today and tomorrow. Like you can attend the sessions today and for the next 2-3 days, right? You can just see what is this big data and why Hadoop require drawbacks with databases, Hadoop advantage of Hadoop ecosystem components. So big data, the name itself saying like huge volumes of data. The name itself saying like huge volumes of data. If you see currently how the data is getting stored, like what are the data storage units, right? Like we see KBs of data, MBs of data, GB, gigabytes, terabytes, petabytes, exabytes, zettabytes, etabytes, sotabytes, so on, right? So from TB onwards, we say like huge data, we say like it's like a big data, right? So you should have seen like KBs of data, MBs of data, or GBs of data, right? But TBs of data or petabytes of data, you should have seen like TBs of data also. Like can you check, right, whether petabytes of data is it getting generated in the current real world? If so, petabytes of data generation, examples of petabytes of data generation, petabytes or exabytes of data generation. If you see like 1 petabyte equal to 1024 TBs, what is that? 1024 TBs, right? Already 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, right? But do you think like petabytes or exabytes of data, is it getting generated or not? Examples of the petabytes of data generation. Yes. Like if you take example of any banking sector like SBI, take the example of an SBI bank. So within a particular city, you see hundreds of branches for a particular bank, right? Within the entire state, you see thousands of branches. And within the entire country, you will see like lakhs of branches for this particular bank like SBI. And in each branch, we see like millions of customers, each customer making multiple transactions per hour, per day, per week, per month, and per year. Each and every transaction need to be stored, right? So like huge transaction, huge data is getting generated, right? Forget about this. Like everyone are aware about social media like Facebook. talk about like Facebook, right? It has got users not only within the country, it has got users throughout the world. Facebook has got users throughout the world, millions and trillions of users, millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated, and what is the data generated by Facebook in a minute, as it has to store all the videos and posts, right? So huge data, right? It's not like MBs or GBs of data generation, like you see like TBs or petabytes of data generated by this Facebook, like millions and trillions of users making like many posts and videos getting circulated, huge data is getting generated, right? Not only like Facebook, today if we talk, right, every application generating data in petabytes, most of the applications generating data in petabytes. For example, just to take 1 minute of transaction, just to take 1 minute of transaction, in a minute, how many FB posts, how many Facebook, what is the data generated by Facebook in a minute? Huge data, right? And what is the data generated by Twitter tweets? Twitter tweets, right? Like huge data is generated by this. And everyone, just you are querying in the Google, right? If any queries, like what is the data generated by Google in a minute? And you're creating your own videos and uploading in the YouTube, right? YouTube videos upload, what is the data generated by this YouTube, and what should be the storage capacity for storing all those videos, right? And millions and trillions of users using email or Gmail messages, email messages, what should be the storage capacity of it, right? Huge data, right? And if I just now I was talking about the bank transactions, right? Lakhs of branches, millions of customer making transactions, right? Huge data getting generated. And telecom transactions, right? Huge data is getting generated. And if I talk like Flipkart or Amazon, like e-commerce systems, right? So like huge data is getting generated everywhere, right? Everywhere huge data is getting generated. Currently, okay, huge data means in petabytes of data is getting generated, right? Currently we have got some databases, for storing the data. We have got like databases like Oracle, MySQL, SQL Server, right? SQL Server, DB2. So all this, they are used for online transactional processing, OLTP, for day-to-day operations, right? And we have got some specialized databases. Used for databases like Teradata, Netija, Vertica. So these are the databases used for data warehouse purposes, DWH. These are used for data warehouse purposes, right? That's for storing huge data. And these are used for online analytical processing. So, but databases are specialized databases. They can handle data up to some extent, right? But huge data or unlimited data is not possible. But huge data or unlimited data is not possible to store. So as a solution to all this, right, for storage level, and not only like storage level, processing level, okay, we have got framework like Hadoop. We have got a framework for Hadoop for storing unlimited data. I'll come back to this, but before this, let us check, right, how the data is getting generated. What are the data storage? How the data is getting generated from the last 50 years? What are the sources from where this data is getting generated? What are the various types? Right. If I take last 50 years of data generation, right? If I take last 50 years of data generation, so think this is the entire data present in the current world, right? If you take from the last 1970, for example, 1971 to 2021, right? Okay, compare, if you compare the last 10-15 years, right, with the last 1971 to, for example, 2011, right, and compare the last 10 years, right, 10 years with the previous 40 years. So just only 20% of the data got generated from the previous 40 years, especially from the last 10 years, like 80% of the data what we see has got generated from the last 10 years. Last 10 years. So what is that reasons for huge data? What is the reasons for the huge data generation from the last 10 years? Means because of usage of technology, because of usage of technology, because of usage of internet, because of usage of smartphones, right? Because of usage of smartphones, especially usage of smartphones, usage of internet has increased a lot, and usage of technology has increased. Like we see everything through online, right? Internet especially, everything through online banking, online shopping, online exams, online education, e-learning, online communications like audio, video chattings, right? Online healthcare, online business, online gaming, right? Everything through online. So data has increased a lot, especially from the last 10 years. What are the main sources? What are the main sources from where this data gets generated? Mainly, I can say like 3 sources from where this data gets generated. 3 sources of data. Like I can say like social data and machine data and like transactional data. Transactional data. Mainly 3 sources like social data, machine data, and transactional data. The data which gets generated from social media like Facebook, Twitter, all this, like we say it like social data, right? Machine data, the data which gets generated by reading or scanning the barcode scanners, RFID chips, such kind of data we call it as like machine data. So for example, if you go to any shopping mall, right, for the items you purchase, right, a big bill is generated, right? So the data which gets generated for reading or scanning the barcode scanners, RFID chips, such kind of data we call it as machine data. Transactional data, day-to-day operations, like what we see like day-to-day activities like banking data, telecom data, right? And this data which was generated, you can see like this data is just, it's going to occupy 3 formats, 3 types of data. Mainly this data is of 3 types, 3 types of data. Three types of data. Structured data, you can see like structured data. Semi-structured data. Structured data, semi-structured data, and unstructured data, right? Unstructured data. Structured data means data which is arranged in the form of rows and columns in a structured format like Excel sheets, data, DB tables, database tables, all this like structured. Semi-structured data which are not fully structured, which is not fully unstructured, like JSON files, XML files, all these are semi-structured. They're not fully structured, they're not fully unstructured. Unstructured like short messages, articles, images, videos, all this comes as unstructured. But if you see like the biggest challenge today, right, the most of the data which got 80% of the data what we see which got generated is mostly going to occupy this unstructured data. It's mostly like unstructured data. So how can we store this unstructured data and how to process this unstructured data? Means if we talk about the current databases, they can handle only structured data. They cannot handle unstructured data, right? So for unstructured data, so to store this huge data and to process this huge data in quick time. So as a solution to all these storage level problems and processing level problems, we have got a framework called Hadoop. We have got a framework called Hadoop, which can handle any types of data. It can handle any variety of data, like structured, semi-structured, or unstructured, right? It is mainly for two things. Hadoop is for storage and for processing. It's for storage and processing, storing that huge data and processing that huge data in quick time, right? Storing and processing. Okay, so storing, one second. Okay, if you talk about any technology, right, either for example C or C++ or Java or Python, all this or .NET, all these are meant for processing. They're meant for what? Processing. And if you talk like Oracle, MySQL, DB2, SQL Server, all these they are meant for storage. So if you talk about any technology, they are meant either for storage or for processing. But Hadoop is for both storing the data and processing the data. It is for performing both, right? Storage, huge storages, and that to unlimited data storage, and high speed processing, performs both storage and processing. Okay, for storing the data. So here, when Hadoop is able to perform both, right? So I got some couple of queries here. When Hadoop is able to perform the storage and Hadoop is able to process the data, what is the use of the current like processing or storage technologies? Do you think they go away from the market when Hadoop is in the market, right? When it can perform both storage and processing, but you need to understand, right? When Hadoop required for huge data, right? For huge data storage and for huge data processing, for millions and trillions of records, not for a, for example, if you're making a transaction, right? For making a single transaction, for that Hadoop is not required for a single transaction, right? So Hadoop is bad for small data. Hadoop is bad for small data. Hadoop is good for huge data. For huge data storage and for huge data processing only, we go for Hadoop. Okay, and for storing the data. Okay, for storing the data, does Hadoop use any databases for storing its data? Does Hadoop use any database for storing its data internally? Right? No. I am saying that we have got some drawbacks with the databases. With despite of these drawbacks, still Hadoop doesn't go with databases for storing its data. So it is Hadoop goes with a special kind of file system called as Hadoop distributed file system. What is that? HDFS, Hadoop distributed file system. And for processing, it doesn't use any current technologies, right? It is going with the execution model called as MapReduce. It goes with an execution model called as MapReduce. Okay, it goes with an execution model called as MapReduce, right? Hadoop is meant for storage and processing. Okay, Hadoop providing two services. One is for storage, other is for processing. We have used MapReduce or Spark. Okay, currently we are going with Spark, right? Fine. Now here, why database? Okay, hope you understood what is big data and why Hadoop. And here, why databases like Oracle is not used for storing this Hadoop data? Why databases like Oracle is not used as the for storing this Hadoop data? Okay, I'm sorry. Coming back, right? Drawbacks with the databases. Just observe this drawbacks with the databases as compared with Hadoop, right? Drawbacks of databases as compared with the first, right? Limited storage. First thing is what? Limited storage. Limited storage means in GBs or in TBs, right? Mostly like it can handle data in GBs or in TBs. We go with the databases and specialized databases, and in most of the databases, no parallel processing, right? No parallel processing is going to happen. No parallel processing. And here, if volume increases, speed decreases. Volume increases, what? Speed decreases, right? If volume increases, speed decreases, I'm saying, right? To justify this, right? Observe this query. Select the sum of amount, the total amount from sales one, right? Assume that you have got some 10 records. Right? Within the sales one. Select the total amount, right? Select the sum of amount, that is nothing but the total amount from sales to from another table, which consists of like 1 lakh records. And observe this, select sum of amount, from sales 3. Right? Think that it has got some 1 crore records, right? So here total amount from sales 1, total amount from sales 2, total amount from sales 3. Which query is going to execute faster among these 3, right? Which query is going to execute faster among these 3 queries? Obviously the first query, right? They're saying the total amount from this 10 records, right? So it's going to execute faster as compared with the remaining, right? Okay. So as volume increase, query to query, right? If volume increasing, speed decreasing, right? Yes. Just 1 second. Give me a second. Yes. Now observe this. Limited storage, GBs or TBs, no parallel processing. As volume increases, speed decreases. And next is, right, if complexity increases, right? Speed decreases, right? Speed decreases. Observe. Take the same query, total amount from sales 1. Okay, think that it has got some 1 lakh reports. See, select the sum of amount from sales 1, select the average amount. average amount from sales one, same table. This time we are taking the same table from sales one only, that, and select standard deviation of amount, standard deviation of amount from sales one, right? From sales one. Okay, sum of amount from sales one, standard average amount from sales one, standard deviation of amount from sales one, right? Okay, standard deviation of amount from sales one, right? Okay, if you observe this query to query, right, which query executes faster among these three? Yes, sum of amount or average amount or standard deviation of which query executes faster when I've got same number of records in sales one. Obviously, again, the first query executes faster, right, as compared with the remaining queries. First query takes less time as compared with, why? Because average amount is a two-step process, right? First sum to be calculated, next average to be calculated. So as compared with the first query, the second query takes more time, right? Standard deviation of amount. Standard deviation of amount means lot of internal processing required. Lot of internal processing is required, right? Standard deviation of amount means lot of internal processing is required as compared with the sum of amount, average amount, and standard deviation, right? So here, lot of internal processing is required as compared with the other thing. So fine. And mainly, the main drawback of databases is databases can handle only structured data. Databases can handle only structured data, right? They can handle only structured data. They cannot handle unstructured or semi-structured kind of data. If you observe this query, right, observe this following query to understand. Observe this following query, right? For example, I want to take reviews for a particular movie. I want to take a reviews for a particular movie, right? Reviews consisting of two columns, right? So just I'm taking like user and giving the review, right? User one, user two, user three. In this way, 100 users giving that user one movie saying that movie is good. User two saying this movie is not good. User three saying that movie is okay. For example, so in this way they are giving the reviews. In this way they are giving the reviews, right? For example, before this, right? So for example, the reviews, the taking reviews of 100 users, yes, users and reviews, users and review. Review, two columns are there, user one, user two, user 100 users, user one saying one, user two also saying once. They're giving the reviews in the form of zeros and ones. One means good, zero indicates bad. They're giving the feedback in the form of ones and zeros. Can you write an SQL query? Can you write an SQL query to count the number of zeros and number of ones? Count aggregation. Can we write an SQL query to count the number of zeros and number of ones? Right? Yes, right? For example, right, just say me that query, right? To count the number of zeros and ones. How many people saying it's good? How many people saying it's bad? Like select review wise, single grouping and single aggregation, right? Single grouping and single aggregation, review wise, count star, review wise count star, from which table? Reviews table, from reviews table, group by review, right? All that output, see the observe this output, all that review wise, right? Ones and zero, grouping all the review wise. Okay, observe that 90 people saying the movie is good, 10 people saying the movie is bad. Okay, this is fine, but generally users won't give the feedback in the form of zeros and ones. They give a review in their own text format. First person saying movie is good, second person saying that movie is not good. In this way, every user, they are saying in their own text format. Now can you count the number of goods and number of not goods? Can you write an SQL query to count the number of goods and not goods, right? Can you write an SQL query now? Can you write an SQL query to count the number of goods and number of bads, right? Not possible, right? Even if you just write a query by counting the number of goods and number of not goods by keyword counter, even it gives wrong computation, as not good is having good within it, right? Not good has got a good within it, right? Okay, so wrong computation. So databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, but Hadoop can handle all varieties of data, structured, semi-structured, and unstructured data, right? Okay. Fine. So like before I go with the Hadoop advantages, right? I'll just give overview of this Hadoop architecture to understand the advantages of Hadoop, right? Hadoop follows master and slave architecture. Hadoop follows master slave architecture. Hadoop doesn't follow like a client server architecture. It follows master slave architecture. Single master, multiple slaves. What is that? Single master and multiple slaves. Multiple slaves, right? Slave 1, slave 2. Master and slave architecture. Okay. This we call as like master node, or like even we can say like in Hadoop terminology, we say like name node. Name node. This slave 1, slave 2, slave 3, slave n. So this we call as like slave nodes or data. We call like slave nodes or data nodes, right? Slave nodes or data nodes. So in Hadoop, for example, think that each slave have got 1 TB storage, 1 TB. They can 1 TB storage, right? Okay, hard disk capacity, right? For example, in Hadoop, data is stored in the form of files. For example, f1.txt file. Its size is like 2 TB. The size of the file is like 2 TB, right? It cannot fit into any of this system. It cannot fit into slave 1, or it cannot fit into slave 2. It cannot fit into slave 3, right? It cannot be stored in any of the slave, as their capacity is only 1 TB. So in Hadoop, how the data is getting stored? It's divided into smaller parts. We have what? It is divided into smaller parts, fixed size chunks. We call them as blocks. So in Hadoop, data is divided into blocks, into fixed size blocks. Each block is distributed across multiple slaves. Each is distributed across multiple slaves, right? It is divided into smaller parts, and the smaller parts we call them as blocks. The blocks are distributed across multiple slaves, means distributed storage. As data is distributed across multiple slaves, data is processed by multiple slaves parallelly. Think that in each slave some 10 lakh records are stored. 10 lakh, 10 lakh, 10 lakh. So data is distributed across multiple slaves and data is processed by multiple slaves parallelly. So here two advantages you can observe: huge data storage and unlimited data storage and high speed processing, very high speed processing, right? So based on this, right, observe Hadoop advantages. Now see this Hadoop advantages, right? Pardon? Hadoop advantages. First one, unlimited data storage. Unlimited data storage is possible. Unlimited data storage is possible. Unlimited data storage because of a feature. There is a feature called horizontally unlimited scalability. Because of a feature called horizontally unlimited scalability is possible. Unlimited scalability. Horizontally unlimited scalability means horizontally unlimited number of slaves can be added. Means for example, you have got a small business, right? You have got less number of slaves. Think that you have got some less number of slaves, right? Think that you have got some only 10 slaves. S1, S2, S10, right? So your business has increased. Your customers have increased. Your branches have increased. Your data has increased, right? Still you cannot go with the same number of slaves. Means if customers increased by 100 times, think that, and data increased by 1000 times, then you cannot go with the same number of slaves, right? Horizontally you will keep on increasing the slaves from 10 to 100, 10 to 50, or 50 to 100, right? So horizontally unlimited number of slaves can be added. That is what scalability means, adding, right? Horizontally unlimited number of slaves can be added. There is no limit on the slaves that Hadoop can have, right? And in the tomorrow session, just I'll be briefing you more, right? Why only Hadoop can go with unlimited data storage? Why not that databases like Oracle, the other things? Why there is a restriction? Why they go with a limited storage? Okay. And high speed processing is possible. High speed processing because of parallel processing. High speed processing because of parallel processing. Parallel processing, right? Very high speed processing and parallel processing, right? For example, one person, for example, if you take non-parallel and parallel, right? We take the example of non-parallel and parallel. One person preparing one item takes 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items, right? Takes 100 minutes. Okay. So in the case of parallel processing, one item take 1 minute only. 10 items takes 1 minute only. 100 items also takes 1 minute. Here 10 persons preparing parallelly 10 items. Here 100 persons preparing 100 items parallelly takes 1 minute. Here as said persons, in our terminology it's a like systems, slaves, right? So I'll just, okay, high speed processing and the other advantages: can handle all varieties of data. Can handle all varieties of data. like structured, unstructured, and semi-structured data. And Hadoop is an open source, no licensing, open source, no licensing is required. No licensing is required, right? So very high speed processing. I'm saying like Hadoop has got very high speed processing because of parallel processing. An example, right? Okay. So Yahoo has conducted a test to check the speed of various databases in the market, right? Yahoo has taken a table of size like 100 TB, right? Consisting of 1024 columns. The task is sorting based on 16 columns. Sorting based on 16 columns. Sorting based on 16 columns. Okay. Yahoo taken a table of 100 TB size consisting of 1024, sorting based on 16 columns. What is the time taken by the various databases? Time taken by various databases. First, Oracle. It has taken nearly 3.5 days to process it. MySQL. It has taken nearly 6 days to process it. And specialized database like Teradata, it has just taken 4.5 hours, right? It has just taken 4.5 hours. Netija, another specialized database, it has just taken 3 hours to process it. Finally, Hadoop. Hadoop has just taken 3.4 minutes to process this. 3.4 minutes. The latest version of Hadoop, it has taken just 1.2 minutes to process it, right? So see that days are hours. Okay, it has taken minutes, right? That Hadoop is proven in the market, processing point of view and also like storage point of view. I'll give multiple examples in the tomorrow session. In storage point of view, how Hadoop is proven in the market, like unlimited data storage, how Hadoop able to store like unlimited data, why not the other databases, and more examples on this, and can handle all varieties of data, right? So Hadoop is proven in the market, processing point of view, like the processing speed of Hadoop as compared with any other, right? It's very less time, very huge high speed processing because of parallel processing. Storage point of view, processing point of view, Hadoop has proven in the market. So today we have got great boom from Hadoop. So most of the projects getting migrated to Hadoop environment, especially like ETL projects, right? You can see like in the Hadoop environment. So, and what I'm going to discuss as part of this course, right? What are the, and I'll just discuss in brief in the tomorrow session about what are the thing, what is that Hadoop ecosystem components, other things, right? But just observe this Hadoop and Spark with SCALA, right? Spark with SCALA. What is, so introduction to this big data and Hadoop, the challenges, advantages, right? And Hadoop distributed file system, right? HDFS, Hadoop distributed file, and MapReduce. It's an execution model, a parallel execution model, right? And data like Scoop, right? It is a data ingestion. It's a data ingestion tool like SQL plus Hadoop. The first two characters of SQL and the last three characters SQOOP. The first two characters and last three characters of Hadoop from Scoop, right? So it's a data ingestion tool like for import or export operation. For import or export operation. Please be in mute. for import or export operations. So for importing data from databases to Hadoop, and also like exporting data from Hadoop to databases, like importing from databases to HDFS, Hive, HBase, right? And also exporting data and performing different types of transformations while importing, right? Okay. It's Swami, please be in mute. So like import or export operations and performing different types of transformation while importing, right? For example, I want to bring only some specific columns or specific rows, or some merging that tables and bringing the data to Hadoop, and different types of aggregations, groupings you can perform before data comes to Hadoop, right? Filtering data, vertical and mergings, right? Groupings, aggregations, incremental import, right? Yarn, yet another resource negotiator. From Hadoop 2 version onwards, we have got many architectural changes, right? Like, okay. So what are those? Everything will be discussed in this Yarn component. Yarn architecture, Yarn architectural components, and Apache Pig. It's one of the processing component. It's like Pig scripting language. So, and also like Apache Hive, right? It's a very in brief discussion on this Apache Hive. Like it's a kind of data warehouse kind of environment in Hadoop framework. This Hive component is used in each and every Hadoop project, right? So what are the different types of tables, internal, external tables, partition, non-partitioned tables, indexing, bucketing, slice, indexing and bucketing, right? And partitioning, static partitioning, dynamic partitioning, multi-column partitioning, and working with unstructured data, working with XML data, JSON data, URL weblog data, and you working with the high UDFs, UDAFs, right, UDTFs, right? And NoSQL database. As a Hadoop developer, you need to have the knowledge of at least one NoSQL database. What are the different types of NoSQL databases? And we are going to discuss a NoSQL database like HBase. HBase is especially designed for Hadoop environment. It's not for open. It's for Hadoop only. HBase works only for Hadoop environment, right? So total that NoSQL database in brief. Apart from this, I'm also going to give a knowledge on this streaming data and technologies like Flume and Kafka. And later we come back to the Spark and SCALA, right? First we discuss about SCALA programming, the SCALA language. SCALA is a language and Spark is an execution model implemented by using SCALA language. SCALA, everything like SCALA data types, variables, and SCALA control structures, collections, transformations, and SCALA functions, everything. Before we go with Spark core programming and Spark comparison with any other technology in the market, and processing wise, I'm going to just compare it. And the Spark data objects we call like RTD, resilient distributed data sets, operations on RTD actions, transformations, computations, RTD persistence features, persistence options, and Spark core programming, fault tolerance model, different ways of creating RTD, and different types of increasing or decreasing the number of partitions, aggregations over the structured data, and different like groupings and aggregations, and various actions and transformations, right? Various actions and the built-in actions and built-in transformations. Okay, one by one, each and every action and transformation in brief. And later like Spark SQL, making the data structured and following, just creating some kind of tables and performing querying on this text using Spark SQL, working with CSV files, JSON files, Spark and Hive integration, Spark and MySQL integration, okay. Working with pure SQL statements. We have got the concept of data frames and data assets, right? And just like a deployment modes, local mode, cluster mode, stages and tasks, driver and executor, Spark submit creation using Eclipse IDE, SBT build tool, and IntelliJ IDE to launch Spark application, and also knowledge on Spark and Cassandra, right? Okay. So this is what in brief I'm going to discuss, nearly like 50 hours on Hadoop and 50 hours I'm going to spend on Spark with SCALA, totally 100 hours, right? So like 2.5 to 3 months I'll be discussing in brief. So you'll get that entire comment on this Hadoop and Spark, right? With multiple examples, working examples, right? So step by step, everything I'm going to discuss with this Hadoop and Spark. Actually, Hadoop and Spark previously there were two separate courses, but combined together, we are going for a very big discount, right? It is an offer batch. So just we are offering this Hadoop and Spark both combinedly at just 10K. 5K for Hadoop, 5K for Spark, just like 10K, it's an offer batch for 100 hours, 50 hours on Hadoop, and nearly 50 plus hours on Spark, right? In brief, in depth, we'll be discussing, right? So even you can attend the session tomorrow and after tomorrow also to see more on this, more discussion on this, right? On storage and processing in Hadoop and Spark, right? So if you've got any queries, right, you can just ask me, right, related to this, what we have discussed till now, and anything related to Hadoop and Spark, right? And as I said, it has got a great boom. You can just check this Hadoop jobs, Hadoop and Spark jobs in the market. You've got many jobs for Hadoop and Spark environment, right? So everyone, you can follow the same link and you can attend tomorrow also. You can attend the session same time with the same link, right, to see more on this Hadoop and Spark. Yes. Query was asked, right? Yes, is how much Java or this Python knowledge required, right? So okay, currently mostly SCALA is used to currently. See here, Spark and Spark with SCALA, Spark is mostly used in the industry currently. Spark with implementation using language like SCALA language, using Python language, right? So SCALA language, SCALA is the native language of Spark. It's built by using SCALA language. So I'm going with SCALA, Spark with SCALA, right? Even also you can implement using Python language, right? So previously for MapReduce, Java is mostly used in Hadoop, but that component has totally got outdated now. It's not much used in the industry currently using, but the other components like Hive is used, Spark is used, the other things, right? We'll be spending more time on those, right? Instead of going with the outdated topics. So I can say I'll be just discussing SCALA language, right? So not a problem, right? So basics of Linux or basics of SQL knowledge required, right? The prerequisites for this. Even if it doesn't have the idea, just I'll be giving, before I go with the practicals, I'll be just giving you that knowledge on those both, right? Things. Not only thing is every day, everyday practicals, if you're performing and if you're understanding the things, right, it makes. So there will be nothing complex here. Everything looks very simple and easier if you are doing the practicals every day, that day itself, right? And you can just the sessions will be like interactive sessions. Now you can ask the queries at any time. If they can unmute yourself and you can ask your queries, and through chat panel. Yes. Fine. And I'll be providing you some tasks and assignments like every week or every alternate week to work with, right? So and interview questions also I'll be providing like topic wise. Yeah. Every session is video recorded. You'll be getting the recording of that every session recording. You'll be getting that day itself, right? So if you are absent for a couple of days due to some ill health or due to some office work, right, you can just go through the video and attend the next session, right? And also you will be having a group, a WhatsApp group for technical discussion, for directly interaction with me, right? Okay. Later, once you get confirmed or enrolled with this course, right? Fine. Yeah, any other queries, right?
So for how long these videos are going to be available?
So after you complete, right, so it will be like 6 months. You can just access the videos for 6 months, right?
Is there any chance we can increase the validity?
You need to have separate discussion with that online team, right, for that.
Okay, thanks.
Okay, so If I'm done with your queries, if there are no other queries, right, I'll just sign off for today. Meet you tomorrow, same time with the same link, right, to see more on this, right? Everyone, you can attend the session tomorrow. If you have got any queries, you can ask me in tomorrow's session, right? Fine. Thank you all for your time. Thank you.
Thanks.